Alright, thank you so much for joining. In this class, I'm going to introduce you to polynomials and how to draw the graph of any polynomial. Okay, I will not go into details explaining what a polynomial is and other details. Yeah, but we can just look at the summary. So let's look at the summary just here. Okay, some of the other details that I may leave out, you can read more on this topic. Okay, it is very important to know the definition of what you are doing, and so here we have a definition of our polynomials. Okay, so the definition is that that polynomial you hear about, or that polynomial you see, is nothing but an algebraic expression which consists of variables and coefficients. Okay, and for that we have types of polynomials, and the types of polynomials involves what we call monomials. Okay, so monomials, these polynomials containing only one term. Okay, that term can be a constant like 5, it can be anything like 5x, it can be 6xy, it can be a negative term. As long as it is just one term, then that is a monomial. Okay, it is a type of polynomial. It is a polynomial of that type. So we go to the second one, that is binomial. Okay, so a binomial, that is a type of polynomials consisting of two terms. All right, so like we have here negative 4x plus 2, you can have ab plus ay. Okay, we have what we call again trinomials. So trinomials, these are polynomials containing three terms. So like we have here, we have 4x squared plus 2x minus 2. Okay, that is a trinomial. All right, now every polynomial has a degree of its highest power. Okay, and we call that the degree of a polynomial. Okay, so its highest power of its variables is what we call the degree of a polynomial. Let's look at the example. Okay, so the first one being constants or zero polynomials. So constants, that is any number, unchangeable number. Okay, like 3, this is a constant. Okay, so this is a polynomial. It's a type of polynomial which is just consisting of one term. Okay, and that term is a constant. Then we have what we call linear polynomials. So linear polynomials contains variables. Now the highest power for the variable is raised to the power 1. Okay, so the highest power of that variable is 1. Okay, so the variables contained in linear polynomials, the highest power is 1. Okay, and then we go to quadratic polynomials. So polynomials, quadratic polynomials, the highest power of the variables is 3. Okay, then we have the cubic polynomials, the highest power is 3. Okay, I mean for quadratic polynomials that's 2. Okay, for cubic polynomials that's 3. For quadratic polynomials that's 4. Okay, as you can see. All right, so there may be a number of variables, but we look at the highest power among the variables there. Okay, so for quadratic polynomials that's 4. All right, now we can look at this example that we have here. Okay, so in this example we want to draw the graph of a polynomial y is equal to x squared plus 3. All right, so how do we draw this? How do we graph this type of a polynomial that we have been given? The best way to use is this one here. Okay, but when you know this topic, you know what a polynomial is, the details about polynomials, the properties, you won't even need this box. Okay, some of the questions you just be doing them directly. All right, so for this one, to graph this polynomial on our x or y plane, so remember this is our y and this is our x axis. So we choose our x variables. Okay, we choose our x variables. In this case, I've chosen starting from -3 to +4, okay, as my x variables, and then my y variables, that is here, I'll be finding these variables using the polynomial that I'm given. Okay, so I'll be assuming if the value of x in this polynomial was -3, what would be my y value? Okay, so if it was 3, then I'm going to have 10 here. If my x was -2, I'm going to have 5. If my x was 1, I'm going to have 2. If my x is 0, I'm going to have 1 as my y value. And then if my x is 1, I'm going to have 2 again. I'm going to have 5. If my x is 2, if my x is 3, I'm going to have 10. If my x is 4, I'm going to have 17. Okay, so you can proceed if you want. Okay, with your x values, you can keep choosing your x values and use the equation here to solve for y values, and then we can use these values that we have produced now to graph our polynomial. Okay, so we have -3, 10, -3, 10. When you check, look at the graph here, it should be this side, -3, 10. Now we don't have 10 in the y-axis. Okay, it's outside our range. Okay, so we go to the second one, that's -2, 5. Now -2, 5, it can be found here, right? So that is our point. And then we have -1, 2. -1, 2 is here. Okay, and then we have that is 0, 1, 1 in the y-axis, that is here. Okay, and then we have 1, 2 again, so that point is going to be there. And then we have 2, 5, again that point is there. And then the remaining ones, if you extend in your y-axis, then you can plot them as well. That is 3, 10 and 4, 17. Okay, but the ones we've plotted so far, we can use them. Okay, so now you need to connect the points so that you can form your graph. It should be smooth. It should be smooth. Okay, and you need to connect those points. Let me just redo this one because the point, we've left the point outside, which should never be the case. Okay, we need to pass through that point. Okay, like this, and then it goes there. All right, so this is how your graph will look like for this type of polynomial that we have. Okay, so this graph is for the polynomial y is equal to x squared, right, plus 1. So these coordinates are connected by this equation. Okay, now let's look at question A here. We've been told to use the graph, okay, to solve the equation, this equation, x squared plus 1 is equal to 3. So how do we do that? Let's do it from here. Okay, let us do it from here. So what we do, we subtract here, okay, the polynomial that we have, or the equation that we have, which we have used to draw our graph, okay, which is x squared in this case. So we have x squared there plus 1. Okay, now we are going to again subtract this equation that we want to solve, which is x squared plus 1 is equal to 3. All right. Okay. Now subtracting this, what you are getting is, so we have y minus 3, that will give you 1 minus 3, right? X squared minus x squared, that will give you a 0, right? And positive 1 minus positive 1, that will give you a 0. So we have this is equal to 0. Now this is same as having our x, our y is equal to positive 3, right? Now we need to get the solution from the graph, okay? We are using the graph. So to get the solutions from the graph, we need to plot this line, okay? That is y is equal to 3. Now y is equal to 3, it will pass just here at 3 in your y-axis, right? So it will pass at 3, that is here. Okay, it should pass there. All right, that is your line. So now to get the solutions, you look at where it is touching your points, okay? Where this graph, that is y is equal to 3, is touching your graph. So we have at this point, this is 1, 3, right? Okay, this side, and then this side, it is touching our graph at the point negative 2, okay, comma 3, right? Okay. Okay, so in this case, these will be our solutions. So for this one, our solutions are, we have negative 2, 3, and okay, and we have 1, 3. So these are our solutions. Okay, now next, that is B. We want to find the gradient at the point 1, 2. Okay. Now the point 1, 2 is right here. Okay. Remember I said your graph, when you draw it, it should be very smooth. Okay. Now let me just try to correct this. Okay, like this. Let me now do this here. I just want to try to make things perfect here, right? So that you can see I'm going to answer this question B. So how do we calculate the gradient at this point 1, 2? So 1, 2, that is the point we have here, right here. Okay, let me use a different color. Okay, that is 1, 2 is the point we have at this point here. Now remember, you need to draw a straight line because okay, a gradient, for you to find the gradient, you need to draw a tangent at this point. Okay, now a tangent is nothing but a straight line that touches the curve only at the surface, okay, just at one point. All right, so to do that, we can draw that line. Okay, you can start from any point you want. Okay, you can plot that one. Okay, and it should touch your curve just at one point. All right. Okay, let's say it's here. Okay, you need to choose where to end your drawing. Okay, where your tangent will end, because you don't want to struggle locating the points. So like in this case, I've put it at 2, 4. Okay, this side 2, 4. This is where it is ending, right? And then downward, it is ending at negative 1, 2. I mean negative 1, negative 1, so that I can use now these 2 points to calculate the gradient. Okay, I've solved a lot of questions involving gradient, so you can just scroll up and check on some previous videos. Okay, so the points we are getting after drawing our tangent at that point 1, 2, where we want to find the gradient, because the gradient will be the same. Okay, so we have that is -1, 1, right? Okay, so we have -1, 1 here. So we have -1, -1, okay, and then we have also 1, 3. Okay, so you can get this one to be your x1, okay, your y1, right? So that you can use the formula, and this one can be your x2, okay, and this one your y2. Okay, now applying the formula for the gradient, we know that gradient is equal to y2, right, minus y1. Okay, this we are going to divide by x2 minus x1. Okay, now substituting, that is x1, okay, that should be x1. Now substituting, our y2 is 3, so 3 minus 1, so we have 3 minus 1, okay, and then over, we have our x2 is 1, okay, minus 1 again. Okay, now this is giving us, on top we have 3, okay, and our at the bottom we have, that is positive 2, right? So this is the value of the gradient, right? So our gradient here, which is m, okay, let me just write the final answer here. So our gradient is equal to 3/2. Okay, so this is how we graph polynomials, okay, and then this is how we find the gradient as well. Okay, first you draw the tangent at that point, and then you get the points. Okay, it's up to you the points where you want your tangent to end, and then you get those points, use them to calculate the gradient. Okay, so for more questions, let's solve in the next video. Thank you.